Okay, number 7 says, thanks for getting those shades. 3x plus 1 over 2x squared plus x minus 6. And what are you supposed to do? Find all numbers that are not in the domain. Then give the domain a set builder notation. So when you're finding a domain of a rational function, you're trying to find out all the real numbers that you can plug in, which are going to be all the real numbers that don't make the denominator 0. So you're looking for the numbers that do make the denominator equal to 0. Those are the ones that are not going to be in the domain. So what's that big word that you need to do to the factor? And we're looking to factor the denominator. So we can't factor the numerator. It doesn't really matter. Does the denominator factor into anything? What does it factor into? Excellent. So therefore, 2x minus 3 equals 0, or x plus 2 equals 0. So 2x equals 3, x equals negative 2, or x equals 3 over 2. So what would the answer be in set builder notation for the domain?
X is such that it cannot equal
negative 2 or?
0.
Yep, there. That's the domain right there. This right here is the domain. Excellent. Good job. Because you can't plug those numbers. Yes. Z. So you end up with z times what? 3z plus 1. And what can you factor out of the bottom? 6. And this is going to be 3z plus 1. What cancels? Ooh. So you end up with z over 6. Good job. Rourke. The x cancels, leaving you with just. So D can be. The other ones cannot be because of the addition. What can you factor out of the top? So 2x minus what? What can you factor out of the bottom? 4. If you factored out of 4, I think you do 8 would be better. Because if you factor out 8, you end up with 2x minus 5. These cancel, leaving you with x over 8. Nice. Denominator equal to 0? Are there any numbers that make the denominator equal to 0? No. So what's the domain? All real numbers. Because let's try doing this. Can you solve that? Well, it'd be 4x squared equals negative 1. X squared equals negative 1/4. Is it possible for x squared to be a negative number? No real solutions. So is there any way for the denominator to be 0? No. Could the numerator be 0? Sure. Absolutely. Nate. Yeah, the difference of squares. And then what can you factor out of the bottom? That's m minus 5. So what cancels? Whoop. You got it. M plus 5 over what? 4. Done. That's it. No trick there. There's a really cool, I think, a really good rate of return on these. They look really nasty, and a lot of them just go, and the answer's 7. A lot of these are set up to be really nice, too. Okay, we're doing something we've done before, just with new-looking things. So right here, this is adding to what together? What are we adding together here? To what? Two fractions. They happen to be rational functions, but they are fractions. Actually, all fractions are rational functions. What's nice about these two fractions that we're adding together? Same denominator. So if they have the same denominator, we just add the numerators together. So what does this equal, Rachel, if I was going to do this one? Nope. 3y plus x over 5. Is it multiplication? Nope. You have a common denominator, you just add the numerators. That's it. What happens if you don't have a common denominator? You have to get one, right? So, for example, let's say I had 7 over 12 plus 4 over 15. If I wanted to add those together, what would I need? Common denominator. So specifically, we're looking for a common denominator, but usually, how many different common denominators could there be? A lot of them, right? We're usually looking for what common denominator? Yeah, least or lowest common denominator. 12 and 15, what's the smallest? 60, right? What do you multiply 12 by to get 60? So you have to multiply 5 over 5. And what about 15? You multiply by 4 over. So what do you end up with? 35 over 60 plus 16 over 60. Now do we have a common denominator? Yeah. So we end up with 51 over 60. But you need that LCD, least common denominator. That same thing is still needed if we have rational functions. That same thing is still needed if we have rational functions. So, for example, you could have, let's say let's do b down. Let's just do a slightly fun one. These are two rational functions. It's two fractions. Are the denominators the same on this one? No. Can someone tell me what the least common denominator is going to be? Anybody want to guess? Well, I'll rephrase it for you. Let's say I had 1 over a minus 1 over b. What would the least common denominator be? A times b, exactly. So can someone tell me what is the least common denominator going to be for this one? Q minus 1 times q plus 1. Exactly. So what do you have to multiply q plus 1 by to get it? What do we need to multiply by? Q minus 1 over q minus 1. Because what is q minus 1 over q minus 1? 1. We're just multiplying by a fancy form of 1. That's it. Okay, what do we have to multiply this one by?
Q plus 1.
Over. So what do we end up with? We end up with, let's zoom out a little bit. We end up with q plus 1. And what's the denominator? Oh, q minus 1 times q plus 1. And what does the other one become? Minus q minus 1 over what? Q minus 1 times q plus 1. Now it looks worse, but what do we now have? What do we now have? No, we're not canceling. If we cancel, we're back to where we started. But what do we now have? We now have a common denominator. So now what can we do with those fractions? We can combine them. We can do the subtraction. So you're going to get q plus 1 minus q minus 1 over what? Q plus 1. We're doing the same process we did right here, right? What did we need? We needed a common denominator, specifically the smallest one. So we found one and we added. Now, can we simplify this a little bit? Can we simplify the numerator? Yeah, what is the numerator? It's going to be q plus 1 minus q plus 1, right? Over the same thing. I'm not going to multiply out the bottom. I'm going to leave the bottom. Do not multiply something out unless you absolutely have to. Does anything cancel in the numerator? What cancels? The q's cancel because you have q and minus q.
Oh,
Why is it minus Q? Oh.
Right there. See that? So what's left on top? 2. So guess what you have? 2 times q minus 1 times q plus 1. We have now combined those fractions. How many fractions do you see right there? 1. Again, this entire thing was predicated on finding the LCD. What is the LCD? In this case, q plus 1 times q minus 1. But what does LCD stand for? Did you say 16? Are rational functions. If we want to subtract fractions, we need a common denominator. What do you think we should do first before we start looking for a common denominator? Factor. Do that for me right now. Factor those fully for me.
M plus 1 minus 3.
So you get m plus 4 over what? M plus 1 times m minus 3? Excellent. Minus 2m minus 3 over what, Kelly?
M minus 3, M minus 2.
Excellent. Now, do we have the exact same denominator? No. What's common in both of the denominators, though, already? What's something similar? The m minus 3 is in both of them already, right? So the m minus 3 is there and the m minus 3 is there. But what's different about them? You have an m minus 2 and 1. And what's the other one? M plus 1. Can someone tell me what the LCD is going to be on this one? M minus 3 is going to be there. What else has to be there? Exactly. So what do we have to multiply this one by right here? M plus, what's missing from this one? M plus 1 is missing, right? Exactly. It has to be over m plus 1 because you can only multiply by 1. It has to be something over itself. What about this one right here? What do we multiply here? M minus 2. Exactly. And if we do this, do we now have a common denominator? So do this carefully. Watch. Do it carefully. And what did I say about multiplying out? Do not multiply out unless you have no other choice. So what do we have? M minus 2 times m plus 4 over m minus 2 times m plus 1 times m minus 3 minus 2m minus 3 m plus 1 over what? M minus 3, m minus 2, and m plus 1. This looks uglier, but what do we now have? What do we now have, Lauren? We have a common denominator, so what can we do? We can put them together, and what do you end up with? M minus 2 times m plus 4 minus 2m minus 3 times m plus 1 all over what? M minus 2, m plus 1, m minus 3. Now, how many fractions do you see? This is just one fraction, right? It's uglier, but is it just one fraction? Yes. Now, theoretically, could we multiply out the top and simplify maybe? Yeah. For now, we're just pausing here. This right here is the new mechanism, which is you are adding and subtracting rational functions. Is anything different about the mechanism? No, you still need what? Least common denominator. The most frequent, easy to make mistake on these, trying to do it all at once. You're subtracting this. You have to just be really careful. You have to be really, really careful. So what'd you get?
5
times
x plus 2.
Okay.
Plus 2 x plus 5 in parentheses.
Okay, over
x plus 2 parentheses times 5, or x plus 5.
Yep.
And x plus 5 or x plus 3.
You got like that?
Yeah.
Who agrees with that answer right there? Woo, you have some friends there. Excellent. Now, are you tempted to try to simplify and cross things out?
Yes.
Can you cross anything out? No. Can't. The plus, you can't.
Are we allowed to simplify the top though?
Yeah, on this one's nice enough, like it's a gimme, like, absolutely. So this one you could write it as 7x plus 10 plus 20, right?
Yeah.
Over the same thing, absolutely, times x plus 5 squared. That would be fine, yes. But the key is you factored, you found a common denominator, and you did it properly. That was excellent. Yeah, so you have, you factor this, and you get x times x minus 2.
All right,
you get x, and you get x minus 2. So can someone tell me what the LCD is? X times x minus 2 is the LCD. The least did you factor? This is x times x minus 2. So what is the least common denominator?
I didn't.
Oh! So what do you multiply this by right here? The first one you multiply by?
I was so pumped.
What do you multiply the first one by? X over x. What do you multiply this one by?
X minus 2.
Over x minus 2. So what do you end up with? You end up with 3x over x times x minus 2 plus 5 times x minus 2 over x times x minus 2 minus 6 over x times x minus 2. Do you have a common denominator now? Do you have a common denominator now?
My math is right.
Yeah, you do. So you end up with 3x plus 5 times x minus 2 minus 6 over. Now, theoretically, could you clean up the top? Yeah, you end up with 3x plus 5x minus 10 minus 6 all over x times x minus 2. How many x's on top do you have? 8x minus 16 over x times x minus 2. Done. You could, if you want, you could factor the top. What does that become? 8 times. Oh, wait, we're not quite done. All over x times x minus 2. What cancels?
Serious?
Boom. Well, this would be the final answer. That would be really nice. Look at that. This would be most credit. This would be all. That's a good one. It's kind of a cool one. What do you end up? You could multiply it out. You end up with 2y minus y squared plus 8y minus 16 all over times 2 minus y. Anything cancel up there? Oh, yeah, the 2y and the 8y, right? So you get negative y squared plus 10y minus 16 over what? 2 times 2 minus y. And then maybe you could try factoring the top. I mean, negative y squared minus 10y plus 16 all over y minus 2 times 2 minus y. Does that factor? Does it factor? Yeah, I think it does. Y minus 2 times y minus 8 all over y minus 2 times 2 minus y. Anything cancel?
Y minus 2.
You end up with negative y minus 8 all over. It's going to be one. It's negative y. I'm going to do it in a sec. So what's that going to equal? 8 minus y over 2 minus y. There's your final answer.